Now we will discuss serial communicator. In Spandan SCADA systems, serial communication is commonly used to connect the control center with remote devices or sensors. Serial communication involves transmitting data sequentially, one bit at a time, over a physical serial interface like RS-232. Click on Serial Communicator option. Then Add button. A new window will pop up. Add string reader device. Let's name it as Testing Device and click OK button. You will notice that our device has been successfully configured. Now we will drag and add this to middle section with the help of mouse. Now, we will understand each and every parameter. In Spandan SCADA systems, serial configuration involves the following tags. Command tag. This tag represents the command sent from the control center to the remote device or sensor. It specifies the data or instructions to be executed by the device. Response tag. This tag represents the response received from the remote device or sensor after executing the command. It contains the data or information returned by the device. 3. Response length. This tag specifies the length of the expected response from the device. It helps in determining the number of bits or bytes to be received. Response terminator. This tag defines the character or sequence of characters that marks the end of the response from the device. It is used to identify the completion of the response and delimit the data. Command trigger. This tag acts as a trigger or event that initiates the sending of a command from the control center to the remote device. It could be based on specific conditions, time intervals, or user-defined events. These tags collectively enable the configuration and communication between the control center and remote devices in a Spandan SCADA system using serial communication. Port configurations. First, port is serial. When configuring a serial RS-232 port, the following parameters are typically defined. Port specifies the physical serial port to be used for communication, such as COM1, COM2, baud rate. Defines the speed at which data is transmitted over the serial port, measured in bits per second, BPS. Common baud rates include 9, 6, 0, 0, and 1, 9, 2, 0, 0 and 3, 8, 4, 0, 0 and 5, 7, 6, 0, 0 and 1, 1, 5, 2, 0, 0. Data bits determines the number of bits used to represent each data character. Common values are 7 or 8 bits. Parity specifies the parity checking method used for error detection. It can be set to none, no parity checking, even parity, odd parity, mark, parity bit always set to 1, or space, parity bit always set to 0. Stop bits determines the number of stop bits used to indicate the end of a data character. Common options include 1 or 2 stop bits. Timeout sets the duration of the timeout period, which is the maximum allowed time for a response to be received before the communication is considered unsuccessful. It is typically specified in milliseconds, ms. These parameters are crucial for configuring the RS-232 port to establish reliable serial communication between devices in a Spandan SCADA system. Net port configurations is UDP. When configuring a serial UDP, user datagram protocol, port, the following parameters need to be defined. IP specifies the IP address of the destination device or the IP to which the UDP packets will be sent. It can be a specific IP address or a network broadcast address. Port defines the UDP port number on the destination device. It determines the specific application or service to which the UDP packets will be sent. UDP ports range from 0 to 6, 5, 5, 3, 5. 3. Timeout sets the duration for which the sender will wait for a response from the destination device before considering it as a timeout. It is typically specified in milliseconds. These parameters are crucial for configuring the serial UDP port to establish communication over a network using UDP protocol. They determine the destination IP address, port number, and timeout duration for transmitting and receiving UDP packets. Nest port is TCP server. When configuring a serial TCP, transmission control protocol, server port, the following parameters need to be defined. IP specifies the IP address on which the TCP server will listen for incoming connections. It can be a specific IP address or set to listen on all available network interfaces. Port defines the TCP port number on which the server will accept incoming connections. It determines the specific application or service that will handle the TCP connections. TCP ports range from 0 to 6, 5, 5, 3, 5. Timeout sets the duration for which the server will wait for activity on a TCP connection before considering it as a timeout. It is typically specified in seconds. These parameters are crucial for configuring the serial TCP server port to establish communication over a network using TCP protocol. They determine the IP address, port number, and timeout duration for accepting and handling incoming TCP connections. Last but not least, port is TCP. TCP-based communication over a serial port, known as serial over TCP, the parameters you mentioned would be applicable. In that case, the configuration parameters would be as follows. IP specifies the IP address of the remote device or server to which the serial port is connected. It identifies the network location of the device. Port defines the TCP port number on the remote device or server to which the serial communication is established. It determines the specific application or service that handles the serial data over TCP. Timeout sets the duration for which the communication will wait for a response from the remote device or server before considering it as a timeout. It is typically specified in milliseconds, ms, or seconds. These parameters are relevant when configuring a TCP-based serial communication connection, where the serial data is encapsulated within TCP packets and transmitted over a network.